Hello everyone, welcome to the next session of Python language tutorial. Today we'll start with module 3, Python language basics. This is one of the most important modules. Here we'll learn Python basic syntax, Python variable types, Python basic operators, decision making, loops, numbers, and strings. So let's start with basic syntax. In this, we have different sections: Python identifiers, reserved words, lines and indentation, multi-line statements, quotation in Python, comment in Python, using blank lines, waiting for the user, multiple statements on a single line, multiple statement groups as suits, command line arguments, parsing command line arguments. Python identifier. A Python identifier is a name used to identify a variable, function, class, module, or other object. An identifier starts with a letter A to Z or small a to Z or an underscore followed by 0 or more letters, underscores, and digits 0 to 9. Python does not allow punctuation characters such as at the rate, dollar, and percent sign within identifiers. Python is a case-sensitive programming language. Please remember this. We have seen some other languages which are not case-sensitive, but Python is a case-sensitive programming language. Thus, manpower with capital M and manpower with small m are two different identifiers in Python. Here are naming conventions for Python identifiers. Class names start with an uppercase letter. All other identifiers start with a lowercase letter. So whenever you see something start with a uppercase letter, you can think that of a class. Starting an identifier with a single leading underscore indicates that the identifier is private. Starting an identifier with two leading underscores indicates a strong private identifier. If the identifier also ends with two trailing underscores, the identifier is a language-defined special name. Reserved words. Like all other language, Python also have some words with a reserved. The following list shows the Python keywords. These are reserved words and you cannot use them as constants or variables or any other identifier names. All the Python keywords contain lowercase letters only. And, as, assert, break, class, continue, def, del, elif, else, except, execute, that is exec, finally, for, from, global, if, import, in, as, lambda, not, or, pass, print, raise, return, try, while, with, and while. We'll learn to use how to use these words in later sections. Line and indentation is very important. Python does not use braces to indicate blocks of code for class and function definitions or flow control. So some of you here may have know C or Java language, and you know one of the base issue we face with missing braces. where we put the braces, but we start a brace, but we forgot to close it, and that gives a error. So in Python, we do not use braces. That is a good thing. So then how we denote a block of code? A blocks of code are denoted by line indentation, which is rigidly enforced. The number of spaces in the indentation is variable, but all statements within the block must be indented the same amount. I'll show this with an example. You can please try this on your console. If true, print answer, else print answer. So to explain this, anyway it will print answer because I have not given a condition for the true. Now this code is running. But don't go into the if else logic. We'll go to the if else logic in later section. Understand? If true, and then in next line, print is starting with an indentation. It is this much space. And else, that means this is a block of code here. And else, and then again print. In your mind, you can think it of like this. If you are used to using codes, then you can think it of like this. But in Python, we don't use braces, so braces are not required. We use only indentation. So if I want to add one more print, I will add it here. Not print. Let's try out this one. If true, print answer, print else, print answer, print false. What will happen if I run this? Yes, this will give me a syntax error, invalid syntax. Because if I will explain this by using braces. This looks like this. So you understand? After if, the else is outside the brace, which does not make any sense. Now this else, so now this else is running without if. That's why it is giving a syntax error, because else cannot run without if. So this explains that in Python we don't use braces, but indentation is very important. To make this correct, what I can do, I run this, is giving the answer true. So this indentation has to be followed. This Python, all the continuous lines indented with the same number of spaces would form a multi-line statements. Statements in Python typically end with a new line. Python, however, allows the use of line continuation character to denote that the line should continue. So that means when you are ending one line, that means your code ends there for that line. If you want to continue that line, you have to denote it with a slash. Let's try this code. I have already written in the console. String hello, then plus slash python plus slash world. Last line there is no slash because this is the end of line. Now what if I print this string? Hello Python world. The point to remember is for Python, these three are not separate lines. Just reading as hello Python world. These are continuous. If you want to put it as different, then you might have it this way. So if you see here, first it is printing the string world, then it's good and bind. Both are separate. But now I want to print goodbye in the same line. What I will do, not need to use this. Do not need to use string 2. Goodbye. Right? So this way we can use multi-line statements. Moving to next. Quotation in Python. Python accepts single quote, double quote, and triple quote to denote string literals. As long as the same type of quote starts and ends the string, the triple quotes are used to span the string across multiple lines. For example, all the following are legal. Word, sentence, paragraph. Let's try this. Word, sentence, paragraph. Now, this is an exercise. So you should also try this in your console. Now, if I print this, it will give me word, sentence, and a paragraph. So word with single quote, sentence with double quote, and when there is triple quote, that can continue to next line. Comments in Python. A hash sign that is not inside a string, literal, is the beginning of a comment. All characteristics after the hash up to the end of the physical line are part of the comment and Python interpreter ignores them. For example, first comment print hello Python, second comment. We'll try this out. You can type a comment on the same line after a statement or expression. name John Chambers. This again comment. First comment, print hello Python. Second comment, so it is apparently this comments. This is a comment. This is also a comment. Python does not have multiple line commenting feature. This is a disadvantage. In Java or in other languages we have, but in Python we do not have multi-line commenting features. We have to comment line, we have to comment each line individually. You can see the example here. Using blank lines. A line containing only white space, possibly with a comment, is known as blank line, and Python totally ignores it. In an interactive interpreter session, you must enter an empty physical line to terminate a multi-line statement. I will do this. So if you see, if I print something else here, now someone may ask, Python is run line by line. Then if I am giving a empty line, how this can be treated? So inside a line, if nothing is given, nothing is written, Python completely ignore it. Also, if there is a comment in the second line, then also it ignores it. Waiting for the user. This is important. The following line of the program displays the prompt and the statement saying press the enter key to exit, and then waits for the user to take action. Input /n press enter key to exit. Here /n is used to create two new lines before displaying the actual line. Once the user presses the key, the program ends, and this is a nice trick to keep a console window open until the user is done with an application. I'll show it. Now you see the enter is here. If I don't give this /n of this, we'll start here. Now the command or the code is still running. Once I hit enter, then only the command will end. Now we can try it this way. Now you can take the value whatever you want as a value input through this, and then use it into the code. We'll come to this in the later section of that, how to take value from console. Multiple statements on a single line. The semicolon allows multiple statements on a single line given that no statement starts with a new code block. Here is an example snip using the semicolon. Import sys x equal to f double o sys steady out write x plus slash n. Don't get into the detail. You may think what is sys steady out, why write. Don't get into that. Just think about the semicolon. Import sys x equal to f double o, then sys stand out right. So these are three part of code, three section of code, but you are writing it in the same line. Let me explain this in a simpler way. One. Run this. One and two. So four different lines. But I can run this. Got it? So this colon, by using it, you can run a multi-line code into a single line. But this is not recommended. It is always recommended to use separate lines for separate piece of code. Also, if you remember, some of you who knows Java, that in Java we use colon as end of line. It's mandatory, but in Python it is not. At the end of the last code, there is no colon. In Java, colon is used to mark end of line, but in Python, colon is used to mention that this is continuation. Multiple statements groups as suits. Groups of individual statements which make a single code block are called suits in Python. Compound or complex statements such as if, while, def, and class require a header line and a suit. Header lines begin the statement with the keyword and terminate with a colon and are followed by one or more lines which make up the suit. For example, if expression shoot, elif is else if expression shoot and then else suit. Try this. You can try this with this sets of code only. First if expression then this Now you see it's giving 2. Why? We'll come to that later point of time. Here x's value is 5. If x less than 5, then print string 1, that is 1. Else print string 1, that is 2. Because x is less than 5, that is why it is printing 2. That is our not main point of concentration. Main point of concentration is the syntax. So if here is the condition and then the expression, that is x less than 5, then colon. After that, this is called the suit, or you can call it also a body. In this suit can contain multiple prints. Like this complete thing is a suit. Then again else, in else we don't have any expression because else don't need expression. Then colon, next line, the print string 1. And if you see, the indentation is same for every line. This has to be maintained. Moving to next, command line arguments. A command line interface provides a way for a user to interact with a program running in a text-based shell interpreter. Some examples of shell interpreter are Bash on Linux or command prompt. I have seen command prompt in Windows. A command line interface is enabled by the shell interpreter that exposes a command prompt. It can be characterized by the following element: a command or program, 0 or more command line arguments, an output representing the result of the command, textual documentation referred to as usage or help. The two following examples with the Python command illustrates the description of a command line interface. Python -c print real Python. In the first example, the Python interpreter takes option /c for command, which says execute the Python command line argument following the option /c as a Python program. So that means after in Python they are giving /c, that means from here the code is starting. Then you are asking them to print real Python, code is ending here, and then real Python. That is the argument, command line argument. Another example shows how to invoke Python with -h to display the help. Python -h usage Python option /c command a mod file and arg. This is all generated by default. -h will give you as a help text. Now this is very important. You can also program your script in such a way that it should accept various options. Python provides a getOpt module that helps you parse command line options and arguments. We'll not try this here right now. We'll test it in the later section because we need to do this with the command line parameter from command prompt. Python test.py argument 1, argument 2, argument 3. Argument 1 is always the final. The Python sys module provides access to any command line arguments via a sysargv. This serves two purposes. Sysargv is the list of command line arguments. Length of sysargv is the number of command line arguments. Right now, we will not use it, so just remember it, we'll use it in later point of time. Here is sysargv0 is the program, either script name. 0 because it's the first position. Let's check this example. You can try this in your command line console. Example, consider the following script test.py. import sys, print number of argument, length of sys arguments and arguments, print argument list, str is string, sys of argv. Now run the above script as follows. This is from command prompt. This is from my 32-bit system. You go there, python test pi, that is the file name. As I mentioned, the first argument after Python is always the file name. Here we are running the script or the file test.py. Then we are giving the arguments. It is asking for argument. How many arguments? 1, 2, 3. So then what is it printing? Number of arguments. So number of arguments, length of this argv. What is the length? Test pi 1, 2, 3. As I mentioned, test pi is also considered as an arguments. So there are 4 arguments here. Now argument list, that is test pi 1, 2, 3. What is a list and how we use this len, str, these commands? We'll explain into the list section. This is an exercise, so you can try this in your home for command line argument. Write a program that accepts command line argument and displays item. Import sys, print number of arguments, then sys arguments, print argument list str sys arg. For I in range 1, length of sys arg, print sys arg.